I am using scikit-learn say as interpret as characters LeaveOneGroupOut say as for cross-validation. Break time 300 milliseconds. This technique divides data into training and testing sets based on predefined groups. Break time 300 milliseconds. It's like dealing cards. We make sure each player gets an equal chance to beat a dealer test set. Break time 300 milliseconds. This shows how I've grouped my 10 samples. Break time 300 milliseconds. Notice that there are 3 distinct groups, 3 samples in group 1, 3 in group 2, and 4 in group 3. Break time 300 milliseconds. It's like sorting candies into different jars based on color. I have 10 total samples of data that I need to divide for cross-validation. Break time 300 milliseconds. Think of these as individual students in a classroom. Break time 300 milliseconds. Based on the groupings, I see 3 unique groups of samples: group 1, group 2, and group 3. Break time 300 milliseconds. This is a key point for say as interpret as characters LeaveOneGroupOut say as method. Break time 300 milliseconds. Since say as interpret as characters LeaveOneGroupOut say as creates 1 split per unique group, I can expect to get 3 splits. Break time 300 milliseconds. Each split is 1 round of training and testing. Break time 300 milliseconds. I have 3 unique groups, so I will have 3 splits. Break time 300 milliseconds. It's exactly the same number as the number of unique groups. Break time 300 milliseconds. In each split, my test set will be the entire group that's left out. So the size changes: 3 for group 1 and 2, and 4 for group 3. Break time 300 milliseconds. This variation might seem tricky. Break time 300 milliseconds. The test set sizes aren't the same in each split, because each group has a different number of samples. Break time 300 milliseconds. In split 1, the size is 3. In split 2, it's 3, and in split 3, it's 4. Break time 300 milliseconds. LeaveOneGroupOut loco is a clever technique in machine learning. I use it to evaluate how well a model generalizes to new data. It's a type of cross-validation, meaning I split my data into multiple parts and train and test my model on different combinations of these parts. Break time 300 milliseconds. The leave one part means I leave one group of data out for testing at a time. The group means that I group the data based on some kind of characteristic before the split. Break time 300 milliseconds. It's a great way to get a realistic estimate of model performance, especially when I have data grouped in meaningful ways. I have 10 data points in total that I will be working with. Think of each sample as a single observation or a row in a spreadsheet. They'll be split into groups. These numbers represent how I have grouped the 10 samples. The first 3 samples belong to group 1, the next 3 to group 2, and the last 4 to group 3. This grouping is important because Loco uses these groups to decide how to split the data. This is the number of times I will split my data for training and testing. With Loco, each unique group will result in one split. Because I have 3 distinct groups 1, 2, and 3, I will have 3 splits in my cross-validation. This tells you how much data I am keeping aside for testing in each split. The size of my test sets will be different depending on the split. In the first split, I use the first 3 samples for testing. In the second split, I use the next 3. In the third split, I use the last 4 samples for testing. This option is incorrect. It suggests that I split the data 10 times, once for each sample. However, Loco doesn't work that way. It uses the groups, not individual samples, to define the splits. Break time 300 milliseconds. This option is also incorrect for the same reason as option C. The number of splits is determined by the number of unique groups, not the total number of samples. This is the instruction to choose the best answers based on my understanding of loco and the given data. The multiple choice options, which I analyzed above, are available to choose from. I am looking at a dataset with 10 samples. This is the total number of data points I'll be working with in my cross-validation. Break time 300 milliseconds. These numbers represent the group each sample belongs to. Break time 300 milliseconds. Notice that I have 3 distinct groups: Group 1 3 samples, Group 2 3 samples, and Group 3 4 samples. Break time 300 milliseconds. This grouping is crucial for LeaveOneGroupOut. This is the core question. I need to figure out how many times LeaveOneGroupOut will divide the data for cross-validation based on the groups I've defined. Break time 300 milliseconds. This option suggests 3 splits, with each test set containing 3 samples. Break time 300 milliseconds. This option also proposes 3 splits but claims each test set only has 1 sample. Break time 300 milliseconds. Here, I see 10 splits, each with 1 sample in the test set. This would mean leaving out 1 sample at a time. Break time 300 milliseconds. 10 splits are suggested here, with 3 samples in each test set. Break time 300 milliseconds. This is the specific cross-validation technique I am using. Break time 300 milliseconds. LeaveOneGroupOut logo is a clever method that keeps all samples within a group. Together, either all in the training set or all in the test set. Break time 300 milliseconds. It iterates, leaving out 1 group at a time for testing. Google style. Nami emphasis. It's all about groups. Google style. I'll determine the correct answer based on my analysis of LeaveOneGroupOut's behavior with A provided groups. Break time 300 milliseconds. I will analyze the options and determine which one correctly describes the behavior of LeaveOneGroupOut based on the given group structure. Break time 300 milliseconds. I am using say is interpret as characters LeaveOneGroupOut say is, which is a emphasis level strong cross-validation emphasis technique in Sklearn. It's a way to split data for training and testing a model, ensuring each part of my dataset gets a turn as the test set. Break time 300 milliseconds. The key here is that it does this based on predefined groups of data points. Break time 300 milliseconds. This list shows me that I have 10 data samples organized into 3 groups. Break time 300 milliseconds. The first 3 samples belong to Group 1. The next 3 to Group 2. And the last 4 to Group 3. This grouping is crucial for how say is interpret as characters LeaveOneGroupOut say is works. Break time 300 milliseconds. I look at the groups array 1, 1, 1, 2, 2, 2, 3, 3, 3, 3 and I see there are 3 distinct groups: Group 1 3 samples, Group 2 3 samples, and Group 3 4 samples. This is the first step to solving the problem. Break time 300 milliseconds. Since say is interpret as characters LeaveOneGroupOut say is creates a separate split for each unique group. I determine that I'll have 3 splits, 1 for each of the 3 groups. That's it. Break time 300 milliseconds. In each split, the test set consists of the entire group left out. So, the first split's test set has 3 samples. The second split's test set has 3 samples. And the third split's test set has 4 samples. The question is a bit tricky because the answer options don't account for the varying test set sizes. I need to think carefully about what would be the most appropriate answer choice. Break time 300 milliseconds. I am working with a dataset containing 10 individual samples. This is my total amount of data. Break time 300 milliseconds. This option correctly identifies 3 splits but implies a test set size of 3 for every split, which is only true in some cases. Break time 300 milliseconds. This is incorrect. It suggests 10 splits, 1 for each sample. Say is interpret as characters. LeaveOneGroupOut say is works with groups, not individual samples. Break time 300 milliseconds. Again, this option also incorrectly states there are 10 splits. Break time 300 milliseconds. This is the best answer choice available. While the test set size isn't consistently 1, the number of splits 3 is correct. It's a case of the available options not being perfectly aligned with how say as interpret as characters LeaveOneGroupOut say as actually works. But it's the closest break time 300 milliseconds. This is my main question. I am asked to figure out how many times say as interpret as characters LeaveOneGroupOut say as will divide my dataset and what the size of the test set will be in each division. Break time 300 milliseconds. I am using scikit-learn say as interpret as characters LeaveOneGroupOut say as a tool that helps me split my data for cross-validation. It's smart because it uses predefined groups to do the splitting. I found that there are 3 unique groups in the data, and say is interpret as characters LeaveOneGroupOut say is makes 1 split for each unique group. That's why I have 3 splits. The size of each test set is different for each split because say as interpret as characters LeaveOneGroupOut say as leaves out an entire group at a time. I found one test set with 3 samples, another with 3 samples, and a third with 4 samples. This shows how my data is grouped. I have 10 samples, and they are divided into 3 groups: Group 1 3 samples, Group 2 3 samples, and Group 3 4 samples. I am working with a dataset that contains a total of 10 data points. Break time 300 milliseconds. This is the overall method I am using. I am performing cross-validation with say as interpret as characters LeaveOneGroupOut say as. Break time 300 milliseconds. It's a technique to evaluate how well a model generalizes to unseen data. I am using say as interpret as characters LeaveOneGroupOut say as loco, a technique in machine learning for cross-validation. Loco helps us evaluate how well a machine learning model generalizes to unseen data by repeatedly splitting the data into training and testing sets. The key here is that it uses predefined groups to do the splitting. We have a dataset with 10 samples. Think of these as 10 individual data points we want our model to learn from. These numbers represent groups that the samples belong to. We have 3 groups: Group 1 3 samples, Group 2 3 samples, and Group 3 4 samples. This is crucial because Loco uses these groups to create its splits. The question is, if I use Loco on this data, how many training testing set splits will I get? And how many samples will be in the testing set for each split? This option says well, get 3 splits and each split will have 1 sample in the test set. That's not quite right. Break time 300 milliseconds. I'll explain why shortly. This suggests 10 splits, 1 for each sample. Google style name excited. That's incorrect. Google style Loco doesn't work sample by sample, it operates on entire groups. Again, this option gets the number of splits wrong. I am using say as interpret as characters LeaveOneGroupOut say as Loco, a clever cross-validation technique. It splits my data based on predefined groups, ensuring each group gets its own time in the spotlight as a test set. Break time 300 milliseconds. Pretty neat. I have 10 data points to work with. Think of these as 10 individual observations, each with its own set of features and a label. These numbers tell me how my 10 samples are grouped. I have 3 distinct groups. The first group has samples 0, 1, and 2. The second group has samples 3, 4, and 5. The third group has samples 6, 7, 8, and 9. Loco uses these groups to create the splits. Loco is what I use to generate those splits. It's like a machine that iterates through my data, systematically leaving out one group at a time to create the test set. Break time 300 milliseconds. It's all automated. Because I have 3 unique groups, Loco creates 3 separate splits. Each split uses a different group as the test set. The test set size varies. In the first 2 splits, the test set has 3 samples, 1 for each of the groups 1 and 2. In the third split, the test set has 4 samples from group 3. This is the core question: how many ways can I split my data using Loco, given the group structure? Option A suggests 3 splits, but implies all test sets are the same size 3. This isn't quite accurate, given the varied group sizes. Option B also has 3 splits, but states the test set size is 1 sample. This is incorrect. The test set size varies among the splits. Option C incorrectly states that there are 10 splits. There's 1 split per group, not per sample. Similar to option C, option D also claims 10 splits, which is incorrect.